Okay, before we move on to the next topic, I just want to give an overview to what we have already discussed. Last week we discussed about regression, linear regression. It's a pretty simple topic actually, but by going through this example, we will have a better picture on what we have already discussed, starting on the data preparation up to the development of a model to correlate input and output. So in this slide, you see two sets of data, input sets and output set. The input set contains two sets of data, x1 and x2, so we have two input sets here, and we have one output set, y. The objective now, we are going to develop a model. In this case, we will just focus on linear regression model to correlate the input x, which is x1 and x2, to the output y. So we have two input and one output in here. So in here, as you can see in this slide, there are 26 points, 26 data for x1, x2, as well as for y. The objective, again, as I have already mentioned, we are going to develop a model to correlate x1, x2, or x in general, to y. Okay, let me switch to MATLAB now to develop this model. Okay, I will start it by assigning the three input and output dataset. I will start it with x1. I will just simply copy and paste it here, not to spend too much time to type it. So I have already typed it before. x1, I assign it for x1, and then this will be for x2. Now I will just copy and paste it again here. So I have typed x2, I have prepared the x2, and then the last one will be for the output dataset, which is y. Same as before, I have already typed it before, so I will just copy and paste it now. Okay, so now I have two input sets, x1 and x2, and one output set of y. The idea now, I want to develop a model, linear regression model, that correlate the input x1, x2 to the output y. The very first attempt, I will just develop a simple linear regression taking into account the two input x1 and x2 and correlate it with the output y. So the very first step, of course, I will prepare the van der Monde matrix. The first column will be just simply a column with all values equal to 1, with a length of the input set. Let's take one of them, x1 or x2, both of them are the same. So I will take x1 here with a column number of 1. Okay, and then the second column will be x1, and the last column, the third column, will be x2. Okay, so if you want to see how x looks like, then now it will be like this. The first column is just column of 1, all values are 1. The second column is x1, the third column is x2. So the first column will be attributed to the constant in our linear regression model. So the next step then is just simply we calculate the parameters. Okay, The parameters, if you refer to the solution of linear regression using fundamental matrix, it will be just simply equal to the inverse of x transpose times x, and then I multiply it with the x transpose and the output set y. So this will be our parameters, where the first element, the first row 0.0576 is the constant. The second element 1.4896 is the coefficient of x1, while the last element minus 0.0666 is the coefficient of x2. So now let's try to estimate the output y based on this model. So let's name it as y1, let's say y1, then in this case will be equal to the input x times the parameter, right? So again, then here y is the true value, while y1 is the estimated values from the linear regression model that we just developed. Just to see how y1 resemble to y, I will just plot it. So I will just simply plot it with respect to one of the input. I will just use x1 in here. I will just put x1 to y, the real value of y. Let's put it with this notation, let's say, and then I will plot it together with x1 and y1, the value of y from the model that we obtained from the model. I will use this notation. Okay, and then this will be the plot.